4 months ago, I announced our next big project after falconry 1 would be TVC. It's finally time for an update. Remember to like, comment, and subscribe, and let's get started. First of all, what is TVC? TVC stands for Thrust Vector Control. So it's basically a way to control the direction of thrust and use that to control the way the rocket moves. This takes away the need for fins. I was inspired to do this by BPS.Space. He's made amazing high-tech TVC rockets and is even trying to propulsively land a model rocket. I suggest you watch some of his videos. A TVC mount usually has two servo motors, one to control pitch and the other for yaw. The servos have a connecting rod that pushes the motor mount and tilts it. The servos are told what direction to rotate in and by how much by the flight computer, which is told by an accelerometer what orientation the rocket's in. But we want to be as simple as possible for the first few tests. Our first design only has one servo motor and won't actually be flown, only static tested on the ground. This is our first design. The bottom part is the motor mount, the part that actually holds the motor. This is the part that's moved around by the servos. It fits 24mm diameter motors, and we're planning to test it with an ST's E12 or an Apogee E6. The E6 will give us more data since it burns for 6 seconds compared to 3 seconds of the E12, but it's also way more expensive, so we don't know if we want to use up a bunch for the first test. The ring part near the top will be stationary. It's the adapter from the mount to the body tube. We're using a BT70 body tube, which is 56mm or about 2.2 inches in diameter. To connect this adapter with the motor mount, we're going to drill a hole through the top of the motor mount and connect it to the adapter with a little axle. At the top is the servo, which will connect to the bottom of the motor mount with a connecting rod. Both the motor mount and the adapter are and have been 3D printed. To keep the mount from falling out or shooting upwards in the rocket, we'll screw in the adapter. The flight computer will just sit above the servo. We're probably just going to use our altimeter and add a few things to it. Lastly is the recovery system. We'll use an 18-inch diameter ripstop nylon parachute from Apogee components. The problem is we can't eject it the normal way. This is because the TVC mount and all the electronics inside will be between the motor and the parachute, since the parachute is at the top of the rocket. In other words, we can't use the ejection charge of the motor to eject the parachute. Because of this, we're planning to use a small solenoid valve. A solenoid is basically an electromagnet-powered piston. At launch, the flight computer will start a timer, and at a certain amount of time after launch, the computer will tell the solenoid to eject. Everything inside the rocket will be connected so that it's only one piece. This will make it so that everything can be removed after each flight and easily improved upon. So that's it for now. It's a very ambitious project with a lot of things we haven't tried before, and I don't know how long it'll take us to finally build our first prototype. We're probably going to make lots of design changes along the way. Make sure to like, comment, and subscribe, and we'll see you next time.